Okay, DC circuit analysis continued. That's the supporting material for today's lecture. We're going to start out with nodal voltage analysis. What is nodal voltage analysis? It's a process that uses KCL to determine voltages. Okay, so it's a process that uses KCL to determine voltages. And what was KCL? Kirchhoff's current law, that current entering a node equals to current leaving the node. Okay, so if you look at this graphics right here, okay, I have the voltage source here, and then I have one resistor, and I'm gonna say this is my R1, which is 10 ohms. Say this is gonna be R2, this is 5 ohms, and say this is gonna be my R3, which is 6 ohms. And I have this independent current source over here, and then independent voltage source over here. The polarity for the voltage source is that you have the positive plate here and then negative plate over here. Okay, when you are doing nodal voltage analysis, there are few steps that you need to take, and then it becomes a lot more easier to do the analysis. Okay, also before I get onto those steps, we can also, since we know the polarity, we can also draw the direction of the current flowing into each of these components. Okay, so you have this current will be flowing over here in this direction, right? And then we'll go here. You also have this current source coming from here, going past this R3, and then these two currents right here will merge at this node, and then this will go right here, okay? Remember, the current is always going to flow in a direction of the higher potential to a negative, to a lower potential. So for example, here, the electric potential is going to be higher at this node compared to this node. So therefore, the flow of the current is going to be in this direction. Okay, right, so just remember that. Now, what are these steps? Well, step one is to find out the total number of nodes in the circuit. Okay, total number of nodes. And the nodes are, we have one node over here, okay, and I'm gonna say this is my, say, VA, okay. We have one node over here, and I'm gonna say this is my VB, okay. I have one node over here, which is VC, and then notice here there's another node at the bottom right here, which is basically common to the voltage source. It's also common to this resistor R2, and also to this current source. And remember, anything that is common to the ground, the potential across it is always going to be 0 volts. Okay, all right. And just to remind you guys, what was the node? Node was whatever that connects the two components. Okay, so if you look at here, if you look at the node VA, that connects the battery over here with this R1, correct? Okay, similarly, if you look at this node right here, VC, that connects R3 and the current source over here, correct? Okay, so we basically have 4 voltage nodes here. So I'm just gonna say number of nodes, number 4. Let's now move on to the second step. The second step is to solve for easy nodes. Solve for easy nodes. Okay, what does that mean? Well, this means that some are the voltages, even if you may start, analyzing your circuit, may be known. Okay, so for example, VD, this right here, VD at the bottom, is equals to 0 volt, right? Because it's connected to the ground. So VD equals to 0 volts. And knowing these voltages can help us analyze the circuit. Similarly, if you look at VA over here, VA is going to be, because this is 70 right here, so VA is also going to be 70 volts over here, correct? So VA is going to be 70 volts. Also, if you look at this current right here, okay, which is 5 amps. This 5 amps is also flowing through R3, right? So your current I3 is also going to be 5 amps, correct? So that is also known, and I'll just write it down here. I3 equals to 5 amps. Okay, all right. Let's now move on to step number 3. What is step number 3? Step number 3 is you have to apply KCL at nodes. Okay, all right. And remember, our goal from this circuit is to find out the node voltages, which is VA, VB, VC, VD, uh, and the voltage and current across each resistor in the given network. Okay, so I'm going to start off my analysis by, at node, say, VB. Okay, at node VB. Okay, and then I can also uh, maybe do something like this. Okay, this is my VB. Okay, the current flowing here is, I'm gonna say the current that's flowing across R1 is, say, I1. So you have I1 over here. Okay, this current that's flowing through R2 right here, so I'm gonna say I2. Okay, so this will be I2 over here, correct? Okay, and then you also have current coming into this node, which is this current right here, and I have already labeled this as I3. Okay, so this is going to be I3. Again, what does KCL says? KCL says current entering the node equals current leaving the node. Okay, all right. So what do we get? I1, current entering this node is I1 and also I3, right? So I1 and I3 are entering this node. I1 plus I3 equals to current that's leaving the node is I2, correct? I got this equation now. Now I can apply Ohm's law here. Applying Ohm's law. The current I1 is actually the current that's flowing across this R1, okay? The voltage across this R1 is actually the potential difference between these two nodes here, VA and VB. And because VA has a higher potential, we know we got 70 volts over here. When the voltage goes through this R1, there's gonna be a drop here. Because the VA has a higher potential than VB, that's why the current direction is like this, and the voltage across R1 is going to be a potential difference between VA and VB. So I1 equals to VA minus VB divided by R1, okay? VA minus VB divided by R1. So this whole thing is my I1 right here. Let's move on to I3 here now. So I3, we already know I3 is 5 amps. So I can just simply write 5 amps here. Let's go back. This is going to be plus 5 amps equals to, let's now move on to I2. What is I2? I2 is the current that's flowing in this resistor R2 over here, correct? Okay, now at this node, we have voltage VB, and at this node, we have voltage VD. Because VD is already 0, so the voltage across 5 ohm is basically the potential difference between VB and VD. So it will be VB minus VD. That's the voltage across the 5 ohm resistor R2. So this will be VB minus VD divided by R2, the value is 5 ohms. Okay, so I get, maybe I can just write it down in a expression format first, R2. So let's plug in the values for R1 and all the known values here. Okay, VA we already know is 70, correct? 70. VB is we are trying to find out. R1 is how much? R1 is R1 is given 10 ohms. Okay. Then I have 5 amps. Okay, equals to VB. Again, this is what we are trying to figure out. VD is 0, so this will be VB divided by R2, and the value of R2 is 5 ohms, so I get 5 here. Okay. Okay, so maybe what I could do here is rearrange this equation such that I get 70 minus VB, okay, plus I get 50, and that equals to 2 VB. Basically what I did, I multiplied this whole equation, okay, by 10, okay. So if I multiply this whole equation by 10, this 10 here and this 10 will cancel out, so I get 70 minus VB, correct? Right? And then 10 times 5 is 50, so I get, and then this 5 right here and this 10, this will, if you do the math, you get 2 VB there, correct? Okay, all right, so I got this equation right here. I'm gonna play around such that take the VB on the right hand side. I don't know why it just keeps going down. Okay, all right, so I get so this will be 2 VB plus VB, so that will be 3 VB equals to 70 plus 50 is 120, okay, and then VB will equals to 120 over 3, which gives you 40 volts, okay, all right. So I'm going to box this value right here, that my VB is equals to 40 volts, okay. Okay, all right, cool. Let's now work on the other uh, values, okay? Now that I know that here VB is 40, 40. So can anybody tell me what is going to be the voltage across R1 here? Which is, I'm gonna say V1 is going to be equals to, yes, folks? What is going to be the expression? If I have 70 volts over here,
30.
30, right, correct. So I would basically get V1 would actually be equals to VA minus VB, correct? VA minus VB. VA is 70, and then VB is 40 that we just calculated. So V1 is going to be 30 volts. Okay, all right, awesome. Also, you know, I can find out I1 now. I1 is going to be V over R1, correct? What V1, let's say voltage across the resistor, which we just determined V1 at 30 volts. So putting 30 here, and then R1 is how much? R1 is 10, correct? So 0, 0 will cancel out. I1 is going to be 3 amps. Okay, cool. Okay, let's now move on to solving for I2. I2 equals to, remember I2 is a potential difference between VB and VD, right? So this will be VB minus VD over R2. Plug in the values. VB is how much? VB we just determined that was 40, correct? Remember VD is 0, so 40 minus 0, R2. R2 is 5. So if you do the math, you basically get what? 8 amps. Okay, so I2 is 8 amps. So let me write down here. I2 is 8 amps. That's the current flowing here. Okay, all right. This current we just determined this was 3 amp. Okay. Do you remember what was I3 here? I3 was 5 amp, right? So if you have 5 amp coming here. So 3 amp going from here, 5 amp going from here. 3 plus 5 gives you 8. So if you look at the current across I2 is 8 amps. And that basically what we had over here, correct? There's one thing that we did not determine here. We also wanted to find out the potential difference over here. Sorry, the VC, correct? VC we have not find out. Again, if I look at I3, okay, I'm gonna say this is I3 equals to, what is I3 equals to? Remember the I3 over here is flowing in this direction, right? From right to left. Therefore, the potential VC is going to be greater compared to VB. Okay, this is our rough estimate. We know that VC is going to be less than, greater than 40 volts, because that's how it makes sense, because the current is moving in this direction over here. So I3 equals to V over R, where V is the potential, V is the voltage across R3, which is going to be the potential difference of VC and VB. So this is going to be VC minus VB divided by R3, okay? Now, if I rearrange this equation, so I will get VC, that's what we are looking for. VC equals to I3 R3 plus VB, okay? Now let's put the values in here. I3 we know is 5 amps. R3 is how much? 6 ohms plus VB. VB we determined was how much? 40, correct? So 5 times 6 is 30. 30 plus 40 is 70 volts. So your VC is going to be 70 volts right here. And then you can go in here and then put that value. So you will get 70. VC equals to 70 volts, okay? So yeah, so everything will start making sense. That would mean the voltage drop across R3 would be 30 volts, okay, V3. So 70 minus 30 will give you 40, okay. So that's your example number 1.